Seniors, as a reminder, you are done with your homework responsibilities for this class unless you have missing or late stuff that you're trying to get caught up on, in which case make sure you send me an email to let me know if there are missing or late things that you would like for me to check in for you. In addition, seniors, if you are scheduled to take the senior exam, your packet, your review packet that you can use on the exam and is worth 5 points extra credit is due by the last Wednesday, end of class on Wednesday. I need that in my hot little hand. Okay, if you'd like to use it and get that 5 points of extra credit on your senior exam, if you're scheduled to take it, you need it by then. Earlier is fine. Okay, earlier is okay. But I need a physical copy in my greasy math teacher hand. Cool? All right, juniors, we're going to continue on into chapter 15, talking about the mathematics of finance. We'll spend at least 2 days on this section. So this is a rather big section. So just kind of keep that in mind. All right. Today, we don't have as much time as I would have hoped. So we're just going to talk about 2 ideas. We're going to get in and get out, and that's all there is to it. So the first idea we're going to talk about is called simple interest. And the formula we're going to use is this. FV equals PV times 1 plus Rn over 100. So FV is future value. PV is present value. R is your interest rate. N is the number of years. Okay, notice that interest rate needs to be written as a percentage. Since it's over 100, you could also drop the 100 and write the interest rate as a decimal. Either is fine, but don't do both. All right, quickie little example. If you invest $2,000 at a 6% interest rate, how much total money do you have in the account after 3 years? So if we assume this is simple, because it doesn't say compounded anywhere, we're going to be using our simple interest formula. So it's asking us how much do we have in the future. That's the future value. The present value is what we're investing now. That's $2,000. The interest rate is 6%, and the number of years is 3. So when we plug this in, wowzers! And you end up with $2,360 if you type that into your calculator and press enter. Mr. Kulik, how am I ever going to be able to do this? This is so hard. No, man, it should be pretty easy. So far, so good? So in a simple interest setting, the only thing that's earning interest is your initial investment. Not the money in the account each year, but just your just your initial investment. The other type of interest is compound interest. So in compound interest, the value of the account is what you use each year to calculate the interest. So in other words, basically you're earning interest on your interest, and you're like, well, that can't make that big of a difference, but boy, howdy does it ever. It makes a huge difference. So our compound interest formula is the following. Now, the only thing that's different letter-wise is now we have this extra value K. And the K just is going to represent the number of compounds per year. So the problem will say blah, 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 percent interest compounded, and then it might say weekly. How many weeks are in a year? 52, so K would be 52. Might say compounded monthly. How many months are in a year? 12, so K would be 12. Might say compounded daily. How many days are in a year? 365. Yeah, and there's a little leftover change there, yeah. It might say compounded quarterly. What would the K be if it says quarterly? How many quarters are in a year? 4, right? Just like 4 quarters in a dollar. If it says compounded semi-annually, what would that mean? 2 times per year. You got it. Everybody's okay with that? So they're going to hide the value of K with a word. Oh no! But as we just kind of ran through, those are like all the scenarios that you might run into. No one's going to have it compounded by seconds or something. That would be super annoying, because how many seconds are in a year? Musical theater people, Rent fans, isn't it in the song? Nobody knows? All right, fine. Get some culture in your lives, though, you know? Go see a musical. All right. Let's take a look at the next example. It says if you invest $2,000 at a 6% interest rate compounded annually, notice that the word compound is in there. That's how we know this is a compound interest problem as opposed to the previous one, which was simple. How much money do you have in the account after 3 years? And then it asks, how much did we gain in interest? So because it's compound interest, there's our formula. It's asking us for the future value of the account. How much money do we have after 3 years? Notice the setup for this problem is the same as before, but now we have this K. What's the value for K in this case? Just once. So if we plug in, notice that it doesn't say compounded monthly, it says annually. Annually is a year. And if we type this into our calculator, I'm not going to put in the times ones. I hope everybody's okay with that. And look, it's more. So $2,382 and about 3 cents. But you're like, Mr. Kulik, you made this seem like a big deal. It's like $22 over 3 years. That's not setting the world on fire here. Oh yeah? What if instead N was 50 years? Let's just check out the difference there. So that's compound interest, about 36,000. What do we have? That's N times R, okay. Big difference there, right? Compound interest, 36,000 and change. Simple interest, 8,000 bucks. Okay, now you have my attention, sir. So the lesson here, short term, simple interest versus compound interest, no big deal. Long term, huge deal. Huge deal. There's a second part to this question asking how much did I gain in interest? Well, how much did we start with? $2,000. So if I take off that initial investment, this extra money must be my interest, right? In general, the interest is just your future value minus your present value. Everybody's okay there? And then I'll drop this in real quick. So as we discussed earlier, we're going to hide the value of K with words. This is just a little quick translation of like what the common words that we might use are. And then I got for you guys just a couple more examples and we are done. Sound good? You don't have a choice. Think 3 more example problems and I'm done. Although this first example problem has like a million parts to it. Oh, Mr. Kulik. It's fine. It'll be fine, guys. It says, suppose Jean invests in a 7% annual interest account. How much money will she have in her account after 5 years as the interest is compounded annually, semi-annually, quarterly, monthly, weekly, daily? So the idea here, what we're going to do is look at how much does the number of compounds per year make a difference, right? We assume that it will make some difference, right? More compounds is probably going to be better. But let's just see for an example. So PV times 1 plus R over, I'm going to use the fraction command here. So my R is 7 over 100 times K, and the first one, K is equal to 1, raised to the N times K power, so 5 times 1. So we have $1,122.04. Actually, let's do this so I can have. And by the way, why am I rounding to 2 decimal places in these problems? because it's money, right? So part B, k is equal to 2, so I'm just going to take the same thing and change the 1s to 2s. Ooh, look. I made a whole extra $6. Amazing. Well, that's pretty good. Next one, quarterly, that's k equals 4. Boy, that'll probably make I'll pick up like another $6 here, right? Is that what you guys think? Yeah, probably. Let's check it though. Oh no, it's only like it's only like $3. Okay. Well, let's see. Monthly, that's 12. Well, that's going to make a bunch of difference, right? That's like way lots of times. Oh, just like $3 more. 8 more compounds, but only picked up an extra $3? And not even $3, really. Okay. The next one is weekly. That's 52. All right. All right, Mr. Kulik. I'm picking up 40 more compounds, and that made less than a buck's worth of difference. Huh. What are we seeing here? How big of a difference does the number of compounds make? A little, right? Makes a little difference. Is it like the end-all, be-all difference? Nah, man. Not that big of a deal. And if I do the last one where k is 365, all right, that's like 300 more compounds, but I just picked up like 25 cents. Oh, okay. So like, sure, the number of compounds per year makes a difference, but I'm not gonna like stress out about the number of compounds per year because like, ain't that much money. What I'd rather have is more time. Time is the big one. I want that time. So for all you young whippersnappers in the room, you take your hard-earned money that you save now and you just put it in like an index fund. You know what that is? It just gives you like the Dow Jones average for the year. That's like the or like the percent gain you're going to get on that. Typically that's like in the neighborhood of like 7-ish%. Any money you save now, by the time you're ready to retire, it's going to be like 100-fold difference. It's pretty good. Telling me that like, you know, 60 years later, 50, 60 years later, that we got my $1,000 now is going to be worth like $100,000 then. That's the power of compound interest. That's the kind of thing you're talking about. All right. Anyway, let's continue on. Another example. It says Maria has $1,000 and places it in a savings account with a 6% annual interest compounded monthly. So I know I'm using the compound interest formula. I know that the $1,000 is my PV. The 6 is my R. My K is 12. And it's asking how long. So we're looking for N to have $4,000. So what kind of an equation are we going to be solving here? Where's the variable located? Bless you, sir. You're welcome. It is in the exponent. To solve this algebraically, what would we have to use to solve an exponential equation? I'll give you a hint. It starts with an L. Logarithm, yes. All right, so to do that, we're going to start by getting the exponential piece by itself. Divide both sides by 2,000. Now, I could turn that into like a fraction, I guess, but I don't really care. I'm just going to leave it like this. To get rid of that exponent base, I'm going to use log base that same exponent. And I'm going to do that to both sides. And then I'll just divide both sides by 12. I'm going to write it as times 1 over 12, though, because it's, I think, a less confusing way of writing it. And then into my calculator it goes. Now, alternatively, what else? How else could I have done this on my calculator if I didn't want to use a logarithm? Does anybody remember? So it takes about 11.6 years. Oh my God. Guys, what did I do here? That's supposed to be a 1, right? Yeep. One moment, please. That's not quite right. Why did I write 1 there? Dope. These are 3s. All right, try that one more time. Those are 3s. That's easy enough fix to make, though. One number. Okay. Except that's not a 3, is it? Good, great googly moogly. 4,000 divided by 1,000 is 3. Who's still on spring break? Apparently Mr. Kulik's brain is. Supposed to be a 4. One more time. 4th time's the charm, right? There we go. 23.6. Was it 6 or was it 1.6? Felt like, yeah, 1.6. There we go. Not my best moment, guys. The algebra was right. Writing down the problem, or the right information in the problem, that was not. Oopsie-daisies. All right. One more example, and I am finished with you guys for today. Sound good? Yeah, I think it's good. It says Gwen has $600 to place in a savings account. what annual interest rate would she need, compounded weekly, if she wanted to have exactly $1,500 in 10 years? Okay, well, this I can tell PV, FV, N. R is what we're solving for, and K is 52. So again, I know it's compound interest because it says compounded in it. So I fill this stuff in. So far, so good. Note, this equation is not an exponential equation because the variable is located not in the exponent, right? Everybody can see that? So, do I need a logarithm to solve this? I do not. I'll still start the same way. Divide both sides by the 600. That can reduce some more, but I'm just not interested in doing it. So to get the R by itself, I need to get rid of that power of 520. How do I do that? Well, it's going to cancel out an exponent. Not an exponent base, but an exponent. I'm going to need to use a radical. What should the index for that radical be? It should be 520. It should be the same as the exponent. So we'll do the 520th root to both sides. Then we'll subtract 1 from both sides. And then multiply both sides by 5,200. And then the R's by itself, right? So into my calculator she goes. The question is probably, Mr. Kulik, how in the dickens are you going to make a 520th root? Well, that's not a big deal. Let me show you. So when it's time to do that, I'm going to type in the 520, and then I'm going to press the math button and pick Command 5. That'll make a 520th root now. And we're all good. So I need about a 9.17% interest. And I'm done. What do you think? Juniors, seniors, I don't care what you think anymore. I know, right? Okay. Everybody's okay then, I guess. So for homework, I'd like you to do 139 to 150. That'll be part of this Sunday's homework set. Reminder that for juniors, last Sunday was due 130 to 138 or something, or 131 to 138.
Yeah.
Okay. So if you forgot to do that or forgot to put it in there because you're on vacation, make sure you take care of that this week and email me that you did it if I've already gone in and graded. I think this class already went in and graded you guys. Looking for them. But that's it. That's all we're going to do today because we're out of here in 5 minutes because everything got so shortened up because of the mass craziness. Next time, we'll continue talking about more financial mathematics, and we'll introduce you to the power of the finance app on your graphing calculator. So if you don't regularly carry a graphing calculator with you to class, I would bring one next time. Okie dokie artichokes. All righty. All she wrote.